I'm going to talk about casting. You're probably familiar with casting from other languages, but in other languages it's really straightforward. You just wrap the type in parentheses and put it before what you're trying to cast. C++, you can do that, but there's other kinds of casts as well. This video we're going to explore static cast. And when you hear static in anything, you should think compile time. It can be statically determined, meaning at compile time. It can be determined at compile time. So key term, that'll raise your salary a little bit if you can get that in your head. Static compile time. Alright, so you see here I have a base class and I have a couple of derives, and I'm going to say base pointer B gets new, and I'm not going to tell you what I'm going to do here. In fact, I'm going to pause the video and I'm going to tab out here to the end of the screen so you can't see exactly what I'm newing up. So here we go, pause, and it's gone. So here I have B. It's pointing to something, but you don't know what it's pointing to, and neither does the compiler. Even though I hard-coded it out there, the compiler won't assume anything. All the compiler knows at compile time, meaning statically, is that B is a pointer to some base. It could be this, it could be this, or it could be this. It doesn't know. Or it could be something else that inherits later if it wanted to. Okay, totally unknown. Statically, it's just a base pointer. All right, so let's go down here. And we want to cast this pointer to something. Alright, I want to downcast it. I want to get the actual type that I put out to the right here that you can't see. Now, it's either one of these three, and only I know, and you'll find out here in a minute. Well, here, I'll just show you. I have to do this. So, I actually typed derived 1, so let's go out here. See, there you go, derived 1. So, I need to make a derived 1 pointer, D1. And I want to assign it the value of B. But that's going to cause an error because B is a more general type, or base is a more general type than derived. So the compiler is going to come around and say, hey, well, that error is not very good. But basically, this is too general. This is derived. The compiler is worried. It says, hey, B could be pointing to a derived too. I don't know. So this might not be safe. Now, now this is where things get dangerous, and if you're doing casting, it should cause you pause anyway, because a little casting here or there, yeah, that happens. A lot of casting, you're doing something wrong. All right, but I know, as Jamie King, I know that I typed new derived element out here, so I know it's safe for me to say, okay, static cast, meaning compiler at compile time, convert B to a derived 1 pointer, because I know it's a derived 1 pointer. I know, I'm confident, I can see it, you can't. Okay, so at this point, I'm down here, I'm safe to use D1, and if derived 1 had some functions in data, I could use it. That'd be fine. Now, static cast here saves a little bit of time because it has no runtime cost. The compiler emits code to just do it. Okay, we don't. I'm going to show you dynamic cast in another video. And dynamic cast, in fact, I should be using a dynamic cast here when I'm casting in hierarchies because it's a little safer. Anyway, let's not talk about that. For now, I'm just saying compiler do it. All right. Now, what if I did something like this? Now we can see out here. Oh, what's it crying about? Drive 2. Oh yeah, this has to be a drive 2 as well. We can see out here that it is really a derived 1. So the compiler will let this compile. Let's build star build succeeded. But if I started using D1 down here, the behavior would be completely undefined, simply because I screwed up as the programmer. I casted this to something it shouldn't be. Once in a while, though, I know my setup, and if I'm absolutely sure, then I'll use a static cast. Again, don't favor static cast or casting in general. Another place to use static cast or casting as general is when you need to be explicit about the type. So, for example, int I gets 25, and say I want the square root of this. Well, if we look at square root, which is in the C standard lib, see, I already brought this in. C standard lib, square root. Well, the overloads are long and float and double. Okay. Well, an int can go to a long, a float, or a double. So if I say square root I, and I don't have the C++ standard memorized, but for some reason, when I say int I, there's no single route that we can go with that conversion. It could be a long, a float, or a double. And so if we build this, it says, hey, ambiguous called overloaded function. And IntelliSense is giving us a little help here, saying more than one instance of overloaded function square root matches the argument list, meaning this could go float, long, or double. I don't know which way you want to go with it. Okay, so we can use, again, static cast to the rescue. Static cast at compile time. Let's do the long version. It doesn't really matter. Okay, long, and then now we got squiggly. More than one instance. Same problem. Well, let's go double then. Double. Okay, now it's happy. So this expression here that I've highlighted, it takes this int, returns it as a double, and then square root of the double version will be invoked. So, and then square root here, I believe it returns another. Okay, double. It takes a double, returns double. I think same is true with float. Double D gets square root of that. So then, if I print out D here, we should get 5. At least I hope so. That's the last time I checked. The square root of 25 was 5. Okay. Anyway, so there's 2 contexts in where you'd use static cast. Generally, static cast, you want to convert direct types. Not generally used for pointers, as I showed in the beginning of the video. Dynamic cast is better for that. But again, casting in general, avoid it as much as possible.